Hi, I'm Peter Haddock and I'm here at bauma and I'm talking peak shaving for the grid to keep your costs down with Tom. Tom, we've got some green behind us, we've got some inverters, we've got some batteries, and the thing about this P-Grid solution is it's designed to save people money, because explain to me why the peak shaving is so important.
Yes, so it's a hybrid unit combining batteries with a generator, optionally also a mains connection. But with the batteries, we can deliver peaks that normally would be covered by a 200 to 250 kVA generator.
Yep.
And we feed it with just a 40 kVA generator.
Wow, and okay, that then saves people a lot of money because they're having to pay their power grid that peak amount, aren't they? So get up to that. When you shave that off, the costs are cut down, aren't they?
Yes, if we're talking generators, we can cut off up to 90% of fuel costs.
90% of fuel costs, that's crazy. So you've chosen a lead carbon battery here because there's a reason for that, isn't it? Because when you're talking about peak shaving, it's about loading and unloading very quickly, isn't it?
Yes, we can also keep the design of the battery pack more simple, more overviewable.
Yep.
Because it is the lead carbon batteries, if you would go to lithium, it becomes all very complex with liquid cooling if you want to be able to do the same heights of peaks. We have them operational in Australia, in America, in Europe, so we are already worldwide.
So the other thing is about getting power into these and power out quickly is the inverters over here. So let's talk about the inverters here. What do we see here and why is this element important?
So we use a UPS inverter. It has two AC channels, so we can feed with something and deliver power to the output at the same time.
Oh, right. So it's literally doing that all the time, potentially, and taking grid power or potentially taking solar power and everything else in at the same time. So it really is your own little microgrid, isn't it?
Yes, you can actually see it as a microgrid unit as well if you connect something up to it like a solar panel or an extra generator or the grid.
So we're going off-grid here as well. So we've got to actually put some power into here if we don't have any grid connection and if we don't have anything else. So Tom, we've come to the other side of the P-Grid, and this is the generator that matters when it's putting in the power. But this is also about managing a microgrid so that we've got, when we need this to be running for power, we're also using that optimized nature of the generator to feed the batteries as well, aren't we?
Yes, correct. So you're running the unit from the battery, and if state of charge goes down, generator will start up. So that also means that the generator always runs in its optimal load point,
right?
Around 75% of the load. Yes.
And that's where some of the fuel savings come in, isn't it? You mentioned fuel savings earlier, and that was significant, wasn't it?
Yes. So up to 90%, but that is where the fuel savings come in. But also, if you run a generator on low load for a long time, you get wet stacking in the exhaust system.
Right.
You get a lot of extra maintenance costs. So breakdowns, especially if you're going to look at the 200 kVA generators, for instance, their AdBlue comes in as well.
Right.
And if they don't run in a good temperature, if they run below 20% load, for instance, the exhaust does not reach the temperature it needs to use the AdBlue, and then it crystallizes.
Right, and that's a big problem when you're off-grid, folks, with this sort of solution, with the P-Grid. And this is why the control system we're finally going to see now is so important, because this makes the P-Grid save money and shave that peak. Tell me how it works.
Yes, so we chose to have just one controller. There's a generator controller inside, and on top of that, we are running our own software in the same box.
Right.
And we have that development all in-house.
And so is this also a connected asset where people can read the data from this actual P-Grid wherever they are?
Yes, so we have a remote monitoring system and people can look into the data, but in case something does happen on site, we can also log into the unit and do a first round of troubleshooting.
Yep.
So that we can also solve some issues like that. But in other cases, people know what they have to bring on site.
So it's really giving the engineers and the service and maintenance team the understanding of what they need to do. So that's great. So also, again, when we're talking about this, we've got a little bit of power opportunity here, haven't we?
Yes.
Because obviously, when we've got a grid, we need a grid because we need to power things, people. So what have we got here within the power element that goes out to whatever the customer needs?
Yeah, so we have a big variety of output connections. We have power locks, but this can be standardized to something to the local markets.
Yep.
And behind this plate, we have input connections for a grid, for solar, or for an external generator, for instance.
So, folks, the P grid is where we need to be if we want to actually do the energy transition and do it in a sustainable way, but also do it in a way that we can combine a generator when it's needed with a battery system and optimize everything, as well as feeding in whatever power we need, isn't it?
Yes, it is.
Fantastic. Great to see you.
Thank you.